going to do a live stream with them. And here's the bigger irony or circle of life. So London Gophers is being hosted at Cloudflare today. And today we have John Graham-Cumming. He's the CTO from Cloudflare. CTO, yeah. And so this is just the whole irony, but the most ironic part is that John actually started London Gophers. So you can see a very cool circle happening here. So this is a very nice moment, I think, for Portugal Gophers and London Gophers. Another very interesting fact is this is our biggest meetup ever. So far, our biggest attendance was about 25 people. And I haven't counted today, someone please count this, but there were 70 people RSVPing in Meetup, and I believe we have around, 40, 50 people here today. So that's a really big step, and I hope to see all of these faces in the upcoming Meetups, because we really need to grow, we want to grow as a community, and Go is also growing a lot as a language. We have more and more companies adopting Go nowadays. Even if you don't use Go or don't know Go, you are always welcome to come to these meetups because there's a lot of things to learn. So yeah, welcome all. We're just waiting. Are they?
So still waiting on the word for them. I guess we can unmute ourselves.
Yeah, it's good in the journal.
Oh, so the mic is on now.
There they are. Hey!
Actually, we're connecting to another Go meetup somewhere else in the world, and the CTO of Cloudflare is going to be joining us from that meetup with just a snack. I need to.
Maybe we can. You can go in front.
Antonio, can we just give Antonio and then a round of applause?
Yeah, I can hold it. So, hi London.
Alright, sorry.
Can you hear us?
Hello, Portugal Gophers. Can we please hand over to you and say hi?
Hi. Everyone say hi.
And welcome as well, John Graham-Cumming, who is CTO of Cloudflare. John, thank you very much for saying a few words. And I'm going to stop talking now and hand it to you.
Well, it's a complete surprise because you're in my office. So, there might be some stuff I need you to get from my desk and bring over. But this was a total surprise. I didn't realize it was going to happen, that we were linking up. I just checked. So myself and a guy called Matt Cottingham started the Go London user group, which is London Gophers, in 2013. So 6.5 years ago, actually. And it was the first meeting was about 40 people, which we've got about 40 people here in Portugal. So hopefully this is going to bootstrap in the same way as London. And have a good time in the office, enjoy yourselves, and I guess I'll be back in London and maybe speaking another one of these meetings.
And you might have noticed that you might have noticed that we also stole Kat from London Gophers is here today.
Yes, hi Kat, and hi Tiago as well, and thank you very much to everyone who's arranged the live stream with Portugal Gophers as well, and enjoy the rest of the meetup.
Yeah, you too. Okay, that was awesome. So I'm going to start off with a few words before I pass the mic on to John. I'm actually taking advantage of some slides that the community prepared because there's a bit of a history behind Go and why it started. So the beginning of Go dates back to apparently Rob Pike, who is one of the creators of the language, waiting 50 minutes for a C++ program to compile. And yeah, basically, this is what you can imagine. Apparently, there are actual swivel chairs involved in this. So yeah, this was the beginning of Go. And their goals was basically to eliminate slowness, eliminate clumsiness, improve the effectiveness, and improve the scale. And for people who use Go, I think they did a pretty good job in all these points. And after 15 months, Go was open sourced on the 10th of November 2009, which is 10 years from, it was 10 years ago. So yeah, that was the first version of the website for Go. It looks straight out of the 90s, but it's been improving. So talking a bit about the present, and in particular, the meetups that have been organized. So we now have 28 Go conferences, 2,000 contributors, 94,000 meetup members in 158 groups, 46 countries, 51,000 members in 54 groups celebrating this event. So yeah, this is basically the same numbers. And out of curiosity, for example, London Gophers, they had 400 people attending. So their limit was 280, and they had 400 people attending. And they have around 3,000 people in meetup group. So we have currently around 300, so it's a big difference. But as John said, let's hope that Portugal Gophers grows. And regarding Portugal Gophers, these are the current organizers. We're always looking for people that will help us organize the meetup with event space, with all everything that comes with it. There's some work to it. But currently it's Anna Gespart. Unfortunately, she's not here now. I think she'll come later. She's the ambassador here at the Volkswagen Lab. Myself, I'm a software developer here, so if you want to know anything about the way we work, you can ask me. Lucas, who is also with us over there. And Paul, I think, is not here today. No. Oh, he is. Oh, right. Yeah, so you can always talk to one of us to know more. Our host today is this office, so Software Development Center. You can come and talk to us. We have a lot of people from the office today. Talk to us if you want to know more. We have this office has actually been sponsoring the Go meetups with the food, with the stickers, with a lot of things. So they're actually one of the biggest sponsors of Go. It's cool when it starts as a company, but you're not actually entitled to anything to the company. They just help us, and they just help this community grow. So yeah, big thanks to Volkswagen. Sticker Mule has also helped us recently with stickers. So they give us 350 free stickers, which you'll be seeing lying around there, and you are free to grab them. And yeah, we already hosted 2 meetups, one at Bright Pixel, one at TalkDesk in Porto. So that's always helpful. If you guys have a place where we can host, come to me, because we're always interested in moving from place to place. And of course, London Gophers were our friends of the evening. So, without further ado, I now pass the microphone to our speaker, John, and he is going to talk about how Cloudflare adopted Go and what they're using Go for, and I'm very excited about this talk. I think it will be very interesting. So yeah, John, passing on to you.
Well, thank you very much for inviting me to talk about this. I'm going to talk a little bit about my personal history, how I got to use Go, because it has quite a long history, and then about what Cloudflare does with Go. The short version is Cloudflare does a ton of stuff with Go. I actually asked in the engineering chat today, I'm going to give this talk tonight, what projects are written in Go, and it just got people to start talking about things. And I knew lots of them, but there are so many. In fact, it is the dominant language in Cloudflare. To give you some kind of scale for Cloudflare, We handle traffic for 22 million domains at this point. We handle 10% of the Fortune 1000. We do about 15 million log lines per second, to give you a sense for the logging infrastructure. So you've used us today without realizing it because you've used an app that has us as the API backend, or you've gone to a website that uses us. People just don't realize that the scale is enormous. And we are the largest authoritative DNS in the world and the fastest. And that's already Go. And so the scale is gigantic, and Go has really scaled very, very well for what we needed. We also use other languages, right? So we also use, there is some C, because we use some things that are based on, it's pre-existing code. There is quite a lot of PHP, actually. The actual Cloudflare website is in PHP. It's a classic PHP website thing. It's a lot of Lua. So Lua we like very much, which I now know means moon. I didn't know that until I moved here. I should have known that, but I was like, that's a cool name. And we use Rust quite a bit as well. And there's quite a bit of C++. There's a lot of different languages, but Go dominates. It didn't 8 years ago when I joined. So, but I want to go through a little bit of history, because one of the things that's interesting is the reason I got excited about Go is you have to go back to 1978. So Tony Hoare, C.R. Hoare here, who invented Quicksort and other interesting things, was at the time at Queen's University in Belfast, and this paper appeared in ACM about this thing called communicating sequential processes, which was the idea being that at some point we're going to have real ability to do parallel things, and what the hell are we going to do? How are we going to write stuff? And so if you sort of take a look at this, he talks in here about, traditionally we've been writing these programs which are entirely sequential, and whenever we try to do parallelism, we try to hide it from people, and there's this lovely thing about developments of processor technology suggest that a multi-processor machine construction from a number of similar self-contained processors, like what we all have, right, may become more capacious, more reliable, and economical than just one microprocessor. So they're like anticipating in 78 there's going to be these multi-processor machines, like how are we going to program them? And it seemed like the existing ways of dealing with parallelism just didn't work very well if we tried to hide it from the programmer. And he said, this I think is really interesting, he said there's loads of methods being proposed, so semaphores, what are called critical regions, monitors, queues, all these sorts of ways of dealing with parallelism, and they seem to work pretty well, but he thought there was a better way, and his better way, it's right down the bottom here, is simple forms of input and output are introduced. They're used for communicating between concurrent processes. So this is literally Go channels, right? So in 78, he was saying we should do this. We should do this communication-based mechanism. And in the paper, he has some examples. So I kind of translated a couple into Go. So this X is a process name. The star means repeat. And then do things, so he declares the C thing to be a character, and then reads from somewhere called West, and then reads a character, and then the arrow is not transmission, it's just the X instruction. So reads from there, and when that's done, outputs it to East. So this is copying from something called West to something called East. Just a simple copy. This is his simplest example. So in Go, it'd be something like this, right? It just translates pretty much directly. And then he writes some other interesting programs. I don't know why, but this was a thing you get a lot about, which is replacing double asterisks with up arrows. But the whole paper is about reading from punch cards and writing to a line printer, and I think this may have been an important translation. So he writes this program. You recognize it pretty much. This is basically a switch statement. If I've received an asterisk, then I'm going to do something special. If I've not received an asterisk, then I just output the character. If I've got two asterisks, I output an output arrow. So the syntax is weird, but it's, this is our program. It's very simple. We have an up arrow Unicode character, so we can go back to that. And then he builds up to this program, and so it's quite funny. So what he does is it reads 80 character punch cards, character by character, and he wants to output them to a line printer, which is 125 characters wide, with basically breaking the lines and putting a space at the end. And he builds up in the paper this thing called disassemble, which is a thing that reads a punch card and gives you character by character on a channel. A thing called assemble, which is a thing that writes to a line printer, character by character. Again, he puts them, copies them together, and these two bars mean run in parallel. So he's basically saying 3 Go routines, essentially. Right, you run these 3 things in parallel, you have some channels for communication between them, and actually hidden underneath this is the disassembler is actually talking about another channel to the punch card reader, but it's all the same communication. So that's 1978. So this is how we probably should handle things. He doesn't explicitly mention synchronization in this yet, but it comes a little bit later on. A year later, he sort of expands on this. Sorry, I have such a bad copy. This is very hard to find this paper, where he's built it up and he explicitly now says the right way to do this is with channels. So he's basically what he says is you're very likely to have the same process replicated multiple times in a parallel system. So you imagine Go on the same Go routine with different parameters, and the way to do it with explicit communication through channels. So he actually has this channel thing, and actually this is a thing for getting a channel and then using it. So it's just like make chan something or other. And the whole paper is about how cool this is going to be. So all of that happened, and then in 1984, this chip was made in the UK. This is a thing called the transputer. Does anybody know what the transputer is? Okay, so Tony Hoare formalized this idea of parallel computation, communication through channels, and then a company in Bristol made this thing. And these chips were, what's interesting about them is they natively supported this style of programming. They native parallelism, and each side of the chip had a communications channel on it, so you could make arrays of them. So actually you could buy boards that look like this. Each one of these is a processor in a 2x2 array where they're communicating with each other. And then you could literally map a program with parallel processes onto either all the parallel processes run one processor, or in fact they can communicate between different processes. Amusingly, when I was in college, we had a load of these because the company that made them had put the silicon die the wrong way around inside the cases, and they had to bin about 2,000 of them, and they were phenomenally expensive. They ran at about 10 megahertz with 10 megahertz communication channels, and so we actually hand wire wrapped, I think it was 16 by 16 array of them, so we could actually use them they were off by 90 degrees basically, but it worked, and you could run this stuff. So this was literally a parallel computer, and there was this great idea this was going to be an amazing thing. This is from one of the programming manuals. So this is a single chip, and they're showing, you could have 3 processors running inside it talking to each other over channels, or you could perhaps have 3 separate chips communicating over those 10 megahertz serial connections. And then you could build arbitrary structures from it. And so you needed a programming language. So this is the programming language, it's called Occam, and you could write things like this. So Seek was just do these things one after another. This is sequential programming. So like call process P1, then we call process P2, then process P3. So what we do all the time, right? Standard sequential programming, and that's an example of a program that reads a value on channel C1, X, adds 1 to it, and outputs it on channel C2. So nothing surprising there. You could translate that into Go in 2 seconds, right? So done with it. And then add this parallel. So this is literally start these 3 processes running in parallel. So it's like go, right? All those things. And this alt thing on the other side is just like a switch statement in Go. So this can receive, let me go over here. This can receive a message which it actually ignores, like it ignores the value of it on count, on the channel count. And if it gets a message there, it adds 1 to a counter, which is local to itself. Or if it gets a message on total, then it will actually return the current value of the counter and 0 it. So you could literally turn this into a switch statement with reading on one and outputting on another. And here in Tony Hoare's model and in the transputer itself, the communication is synchronized. So it's exactly like an unbuffered channel. So this works exactly the same. And this stuff translated very, very directly into the assembly language of that chip. So it was phenomenally fast. There's meant to be a picture of me at college here, but my parents failed to send me one fast enough. So you have to imagine that I was younger in 1996. So but if you imagine that there's by the time I got to college at Oxford, where Tony Hall was the professor, this is what was brewing, right? We're going to do all this stuff with these parallel processes, synchronized communication, this is what's going to happen. And obviously I got indoctrinated. And so I stayed and I did a PhD in formal methods, and it's all about this. So this is actually, I built and proved a file system was secure, first of all in CSP. So this is CSP, sort of PhD level, all the symbols. But this is just a file system. So this is literally, once you look through this, this is, some user can actually read files and write files. And if they write files, if they read them again, they get them back again. So it's really simple, right? It's like store something, get it back. And I could tell you what all these values. Actually, I used to tell you what all these symbols were. I have to go read my own thesis now. But the thing that was interesting was that turned directly into an Occam program. And so it's exactly the same thing here. You can actually kind of see it's like, we'll read a message, and then if it's read, then we'll see if we've got it in, it's actually, that file exists. We might send an error, or we'll send back the file contents. If it's a write, then we'll write it to the store and send back okay. And this was all provable. And what was interesting about this was there were two things going on here. One was this amazing parallel future where you can just write stuff like you can in Go now. The other thing was that everyone was going to prove their programs were correct. Right? So two things happening at the same time. So there's nice algebra and you could write all this kind of stuff. And neither of those things happened, right? So, what happened was, first of all, it turned out that proving things correct was enormously difficult at any real scale. And actually, Tony Hall, 10 years after this, wrote a paper where he said, yeah, we were way too optimistic, and I was wrong when it came to what the real world looked like. And the other thing was that, this simple language was going to take over the world, because it didn't. But what was nice about both Occam and CSP was the syntax was really simple, right? It was kind of, I told you most of it, right? There's also loops, that's it, right? Just like in Go. It was trivial to do parallel. You just said, hey, these things run in parallel. Synchronization was on channel communication, which made it really simple to reason about. And it was really fast. At the time, it was really fast. So anyway, so that was great, right? There's this bright future going to happen, it's going to be amazing, and then nothing happened. So from 92, when I left college, 2009, there were 17 years of nightmare, right? So assembly manuals, list, all this kind of stuff, which I spent all my time doing. Yeah, I should have tried Erlang. Okay, so the other language that really has the CSP heritage is Erlang, but I didn't. The actor model is similar, but the actor model is asynchronous. And one of the key things in CSP, and then in Occam, and then in Go, is that synchronization moment, where you can reason about the synchronization, which makes it so much easier. And then 2009, hey, so as we said, 10 years ago, Google releases this language, and I read about it, and I thought, that's interesting, what's this language all about? And then I read this. I was like, oh, you see, I was ready for this. For 17 years, I've been waiting for this. Like, I knew this was right. I went to university told this was the right thing to do. And finally, it's like, it's happening. We're finally going to get this freaking language back again. And so, what was Go? Go was all those things that we'd seen in CSP and Occam, but had an object model, right? Because when Tony Hall was doing CSP and then Occam, the idea of electronic program didn't exist. It had not been created. A single binary distribution. So, in those 17 years in the wilderness, one thing I had noticed was it was really a pain to distribute software. I spent a long time as a Windows programmer trying to deal with DLLs that were not connected to each other and all sorts of nightmares. So that was fantastic. And garbage collection, because if you've done anything in C, you were in a nightmare situation with garbage. So this was really exciting. And then I joined Cloudflare. So 2 years later, I joined Cloudflare. So almost 8 years ago now. And 5th of December, and 15 days later, I think it was 4,000 lines of Go running in Cloudflare, first checking. This is actually the first commit. I made it out there, and it has a typo in it. So to tell you how genuine it is, it said it should be client, not client. This was for a product that, so what happened to me was I went to Cloudflare, I flew to California, Matthew Prince, the CEO, said, here's a list of projects, go choose one. And I chose one on the way back to the airport, looking at the list, and it was to solve a problem for Cloudflare, which is if you stick a proxy in the middle between a client and a web server, and you have to go back to the web server, so you're not actually doing caching. You introduce latency. And so like, he wrote things like solve the latency problem, which is, and most of the latency problem is the speed of light. So it's like, that's a big ask, and the speed of light is probably fixed. And I'm going to be the one to change it. So, we had to go back and think about something, and the idea was to run a program on the web server, the origin server, and a program on our side, and transparently figure out a way to do compression that was based on knowing the history of communication, and basically by deltaing what was sent over the connection. And so a bit like a sort of rsync type thing, because in fact it turned out that between refreshes on a web page, they change very little. Like a tiny amount of changes. And so the compression ratios on this thing, when it works, is now called Railgun. It's a thing, actually we're close to end of life now because it's been replaced with something else, but the compression ratios of this are ridiculous. It's like, you end up sending 0.1% of the original page size because most of it hasn't changed. So it was all done dynamically. And so I had that running really quickly. And I think that tells you something really interesting, which is like Go is really easy to learn and get going with. And that was 2011. So now I was using pre-V1 Go, so R60, and so Go 1.0 wasn't released until I think July of the next year. So it was dodgy, right? There was a lot of stuff that didn't work, and so we released this thing. We finally released it on Go 1.02, and went into production with it and went live. And one of the nice things is one of the first customers of this was 4chan. And the reason that was nice is that Loot, who I got to know really well, he cared less about uptime than some other customers did, right? So if 4chan went down, he was upset about it, but it was okay, right? Whereas other people might get upset. So he allowed us to experiment with Railgun on 4chan. So if in 2012 you were a 4chan user and it went down quite a lot, that was probably my fault, because I was an idiot who used some language that just come out the door to run a production thing, right? And it was hard work. It was hard work getting it really going correctly. But it did work. And you can read the history of it. But there was some really interesting things. So one of the things that was interesting about Loot is I'd done all of the work on Railgun on Linux and on my Mac. And it worked great. It worked very well. And 4chan was all on FreeBSD. And so we shipped him a binary, we built it for FreeBSD, we shipped him a binary, and every few hours it would OOM kill the process. It would run out of memory. What the hell, this thing works actually really well internally. So, hey, great, we'll start debugging it, we'll start trying to figure out, is there some sort of memory leak, why would it be different on FreeBSD than on Linux? And eventually, I was like, okay, I need to understand the garbage collector of Go, so I get into the garbage collector. Is the garbage collector not collecting garbage? What's happening? So one thing that happens in the garbage collector is that obviously it finds things that are no longer needed, it marks them, later on it's going to go back and clean them up, they might get reused for something else, that space in the heap might get reused. But ultimately, if the garbage collector thinks, I'm really done with this bit of memory, I'll give it back to the operating system, it calls this thing sysunused. And sysunused actually releases a block of memory back to the kernel. And on FreeBSD, this is the code. So this is why 4chan crashed a lot. That was because, in fact, the garbage collector was doing exactly what it wanted, and every time we tried to release a block of memory back to the operating system, we hit. These two macros say, yes, honestly, we did use those two parameters that we didn't use, right? And then this to do, right? So Russ got stakes. So I was there, and I had a conversation with them, and they're like, well, why don't you just fix it? So that's what I did. So I implemented that sysunused for FreeBSD. So this is how I got into Go, because half of it wasn't implemented. So that was November of 2012, so you can see the period at which 4chan was down. And that was interesting. There were things like that that were really, really missing. The other thing that was really fascinating was the syslog package. So we're using syslog, and it turned out that Russ Cox had not actually read RFC 5424, which defines syslog. He just kind of thought he knew what it did and implemented it, and it didn't. So guess what? I implemented that. And so we were actually building basic bits of the functionality. Because syslog existed, but it actually sent you a message that was not the right format. So go off and fix that. And that helped us because we wanted syslog. The other thing that was a real pain was memory. So if you used Go prior to the big change in the garbage collector around 1.4, 1.5, memory pressure was a real problem. And back in 2013, I wrote a very popular blog and talk about how do you not use up too much memory in Go. Now, this has all been entirely replaced by sync pool. So you don't have to, if you have things that you might use over and over again, you can put them in a pool and get them back. But the only choice at that point was to go and do stuff yourself. And in fact, we did this because of Railgun, the memory would go completely haywire. But I showed how to do it. Because actually, for all of Go's promise at that point, the fact that it was garbage collected, it was very immature. And so it was very painful when you were dealing with things, especially when you were taking a lot of, you were creating and destroying a lot of objects at the same size, which Railgun did a lot because it was sending communication back and forth across the network. The other thing was that garbage collector created really big latency problems. So this is from a Google presentation when Go 1.5 came out about garbage collector and latency. And so what's interesting, if you look at this is seconds. And so these are pauses. So you would have pauses in the seconds for garbage collection. And Cloudflare is running a service which you're using, right? You like go to a web page or you do a DNS lookup. And if it pauses for 5 seconds, then you think it's broken. In fact, what you probably do is hit refresh, and then now we've got another request going into our system. And so garbage collection was a really big problem. It actually showed up in public metrics about Cloudflare. What it showed up in was at the P95, P99 latency. So our average latency was amazing. It would be like really, really fast. And then for example on DNS. And then you'd have like this crazy tail latency where it's like, because of course what happened was somebody did the request and they hit the garbage collector pause, and 5 seconds later they got the response. And so we tried all sorts of things to fix this, and then actually we were saved by Go 1.5, which is showing like the size of the heap here. It stayed in milliseconds. So now you don't have to worry about this. So now, what was interesting is even while this was happening, Go was spreading within Cloudflare because it was easy to get started with. That was the number one thing, right? It was easy to get started with. It was easy to write a parallel program. It had a really good library. And also, it had a guarantee it wasn't going to change. And so one of the difficulties with most languages, especially when they're developing, Rust is certainly in this case right now, where I have to rewrite my program, or I have to go back through and do something to my program, whereas Go, I'm sure you can take your original Railgun and compile it, and it'll just work. So that was a big thing for us. And then some stuff was really slow. So Cloudflare does a hell of a lot of cryptography because we're handling HTTPS, we're encrypting links between our data centers, and we needed cryptography to be fast, right? We need TLS to work really, really fast, and we were using Go in a lot of frontline situations. And for different protocols, so this is AES 128 GCM, which is a very, very common encryption, 128-bit encryption used for TLS, and it was really slow. And so what we did was we went off and implemented our own assembly language optimizations and gave them back to the Go community. That made it that particular one 23 times faster to do that. So actually a lot of the high-speed Go crypto stuff was originally written by us because we knew in production it was really, really slow. Now what's interesting, this is Go 1.4. It was still really slow. So even up until like Go 1.5, there were a lot of areas where the language was there, but the actual implementation was kind of immature. So we lived through a long period. Luckily, Cloudflare was so small that, and I was in London and everyone else was in San Francisco, that nobody noticed I was writing anything in Go until I checked it all in, and then it was too late. So I kind of got away with the murder, right? Because it was pre-V1. So, I got away with doing bad things. But we did a lot of stuff. And now actually, this is an area where the Go team has made a slightly controversial decision. They don't want to have assembly language optimizations because they want to really go cross-platform, right? Because they've written Go and Go, and they want to make sure it's cross-platform. So there's kind of some new rules about how they want to do that. They at least want the assembly language to be generated by other code. So there's sort of a change here. But we had to optimize this for different processes. So as of this morning, Cloudflare, we have 22,420 .go files. That doesn't include vendor stuff. That doesn't include any. That's like stuff we've written. Not generated code. I don't know how many. I tried to get the number of lines of code, but it's hard to say. But you know, it has to be in millions of lines of code. So a few things. I'm going to tell you about a few things that are written in Go. So very early on in Cloudflare's life, we used Power DNS, open source DNS server, and a lot of Cloudflare's business logic is actually in DNS. So because we handle DNS for those 22 million domains, we have all sorts of stuff. So we decided to write our own DNS server, and we wrote this thing called RDNS, which is written in Go, and it is the fastest and the largest authoritative DNS in the world, by far, actually. So 11 milliseconds. That's average performance. It's very fast, but it took to get that. We had to get that Go 1.5, where the garbage collection thing comes, because the tail latency was terrible. So this is, if you've ripped up one of those domains, you've gone through a Go program. We haven't really ever talked about this, but we have a thing called Quicksilver, which is a global key value store. And just to sort of talk about what I mean by global, Cloudflare has servers in 194 cities worldwide. And so if you use Cloudflare and you go in and make a change, so you click a button in our UI, or you use the API to change something, that change has to get distributed to every machine globally. And so we built our own key value store to do that. And that is, what happens there is that we will distribute that change to all machines. And this is part of the dashboard which looks at the real-time replication lag. So the replication lag here is about half a second to the whole world. And you're actually running up against speed of light, because the time from the master to New Zealand is actually the speed of light is getting in your way. You're quite a few hundred milliseconds away. So this is in Düsseldorf, and this is in Geneva, and Helsinki, and Hong Kong, right, and so on around the world, Frankfurt. And I think at some point we're going to open source this. The team that's working on it is always like, one more feature, we're going to add one more feature before we open source it. But this is running continuous changes, many changes per second, globally distributed, and that's how Cloudflare keeps up to date. And this includes code distribution globally as well. So we have this thing called Workers, which is a edge computing platform where you can write code on Cloudflare. If you write a piece of code and you commit it and you say you want it deployed, it goes into this key value store and gets distributed around the world and actually starts executing. This is one of the reasons why when you make a code change, and I've done this live coding, where you make a code change and you flip back to the web browser and hit refresh on the page, which is actually backed by that code, it's usually deployed in the time it's taken you to switch between the browser and the development environment because of this key value store. Again, all of them go. Another really interesting technology is a thing called Unimog. So if you think about Cloudflare's history, we deployed in, when I joined 4 cities, and then 20, and so on, and now 194. And over time, of course, it's not uniform in terms of the hardware that's out there. So we're actually about to ship our 10th generation of hardware. So we have machines made for us in Taiwan. They're fairly standard in the sense that Intel CPUs, certain SSDs that we've spec'd, certain amount of memory, disk, all that sort of stuff. But of course, over time, those machines' capacity has changed. So they've got faster CPUs, bigger disks, more memory, better NICs, all this stuff has changed. So around the world, in any data center, you will have many different types of hardware handling requests. And here in Lisbon, we request here, you'll go to one of our data centers in Lisbon, and you'll get load balanced onto one of those machines behind the scenes. And those machines have different characteristics. And so what was happening was, and I'll show you this graph, each of these lines is a server in a data center somewhere, and the colors are the generation of hardware they're running on. And so this is the CPU utilization. So you have a wide range of CPU utilization where there's some of the newer ones are running at something like 50 and some of the older ones at 75. And if we get a flood of traffic, something interesting happens, particularly like sporting events where people come in, what will happen is these machines, these are older machines that are peaking up, they might really peak up and get into trouble, and you have problem accessing the web. And so what we wanted to do was we wanted to dynamically steer traffic to those machines based on the performance of those machines, and do that without configuring it. So we don't actually say, oh, this is a Gen 3 machine, or we actually measure the performance. And so we wrote this thing called Unimog. And what Unimog is doing is it's actually measuring in real time the CPU utilization on machines, and is then deciding how much traffic to steer to every machine. And what this graph shows is, this is how it was running. We actually switched off, we actually drained traffic temporarily to install Unimog. We came back and we enabled it here. And so what happened was, it brought in line every machine to the same rough CPU utilization. And this means that, now if you go peak traffic, it gets more fairly distributed across the machines. And so again, this is written in Go. It's actually doing the traffic distribution. And this runs everywhere in the world. And now we're actually working on the next level of this, which is to do this at the global level, to actually move traffic dynamically globally. But again, a Go program is very, very successful in what it does. And I need to do Go program because it also has to handle catastrophic events. So in July, we had a catastrophic outage where we deployed some software that pegged CPU to 100%. And actually the designers of this Unimog thing have said, what happens if this happens? What do we do in that event? And they built in a kind of safeguard, which is that if the CPU peaked up really, really high, they would not view it as the machine being dead, but the machine being very busy, and would continue to serve traffic. And so rather than it shutting down, because one of the dangers was Unimog could just say all these machines are dead, we'll shut them down. Particularly because one of the things they do is they detect machines that have actually died and take them out of rotation. And actually it worked in real time. We were partly saved by the fact that this thing was able to understand what was happening on the network. So again, a very large piece of code. Another really interesting thing is a thing called keyless SSL. So for some of our customers would prefer not to give us the private keys for SSL. And so there might be, say, banks or other regulated industries where they want to keep the private key, and we'll keep the public key. And we need to have the public key so we can present the certificate. That is essentially the public key. So when you go to a website, we present the certificate. But without the private key, you can't establish the connection. And so quite a few years ago, we came up with this idea of keyless SSL, which is that we would have a key server that could be anywhere. It could be on the same machine, or it could be in another country, where the private part of the communication would occur. We'd set up the communication, which is what's happening in this part here. And the front end part, so this is a web browser talking to us, can do all the normal SSL stuff, and only when it needs to do a private key operation does it go off to this key server somewhere, and someone else can run that key server. And the original version of this I wrote in C. This is on GitHub. And the reason it was written in C was that it linked with OpenSSL. And 2013, so the idea was this thing could communicate with us, do private key operations in OpenSSL, send back the needed material, and then we would carry on with the communication. Now, does anybody know what happened in 2014 with OpenSSL? There was a thing called Heartbleed. That was an absolutely catastrophic bug. We actually had to all of the keys we do, the certificates we do actually handle, which is a very large number. We actually reissued every single SSL certificate that we had as a precaution, because Heartbleed affected the entire industry. And what we showed at the time was it was actually possible, because of Heartbleed, to extract someone's private key from the machine. So except for our customers who were using this, it could have been possible. That didn't actually happen, but there was a fear. And in fact, we went through and revoked so many certificates that the people who monitor certificate revocation thought their software must have broken. Because what happened was the graph was usually like 2 a day, suddenly it was like 100,000. Like, okay, was it broke? But because of that, we completely then eventually abandoned this C program because we wanted to abandon OpenSSL, and we rewrote all of this in Go. So this is now a Go program, so when you connect to Cloudflare, you actually connect to an instance of Nginx which talks to a Go program to do the crypto and comes back to Nginx. And the really interesting thing is because of Go's nice properties of parallelism, that does not have to be on the same machine. In fact, it's often not on the same machine. It doesn't have to be in the same country. It's allowed us to say to a customer, where do you want your private key material? Do you want it on your own server, on our servers? And they can even restrict and say, oh, only in the EU or only in the US. So that's another thing which is running all the time on every request that you're seeing. So again, Go is absolutely everywhere in Cloudflare. Okay, another technology is a thing called Argo Tunnel. So the classic way Cloudflare works is you're a customer Cloudflare, you have a web server somewhere, an API server, you give us the DNS. When a request comes in to us for your server, we connect to you. So we just make an ordinary HTTPS connection to you. And that's great, except that some attackers will try to go around that. They'll try and find where you really are and just attack you directly. And so about 5 years ago, we started saying, well, the right way to do this is that the customer should connect to us rather than us connect to the customer. Then you don't have to have any open ports on their machines. They can just leave it completely closed and connect to us. And the other thing is if they do that, then they can dynamically scale on their side up and add servers or remove servers, add VMs or not, and then Kubernetes came along and thought, okay, well, it can be done as an ingress controller, you can just scale automatically, and you'll just connect to Cloudflare, and Cloudflare will then configure load balancing and make this thing look like one server. So we created this thing called Argo Tunnel, and that does exactly that. This is a program that we distribute. It runs on people's web servers and their Kubernetes and VMs or whatever, connects to Cloudflare, configures Cloudflare completely for them, and then all the traffic to that server passes over this Argo Tunnel connection. So again, entirely written in Go. So, DNS is happening in Go, the security stuff is happening in Go, often the connection actually to the backend server is happening in Go, so what's happening in Cloudflare is all running through Go programs. And a ton more. So, to give you some idea, so, we're quite well known for DDoS mitigation, and our logging pipeline, which is 15 million or so, 10 to 15 million log lines per second, all of that's written in Go, so it's pushing those logs to a single location. Then there is a lot of heavy analytics happening. So here's an interesting use, which is that in the DDoS detection world, you've got a very high rate of messages coming in, and you will need to do all sorts of interesting algorithms on them very, very rapidly. So it's heavy CPU and heavy network at the same time. And we've really proven out that Go works very, very well for that. Because often people say, well, it's not very good in a heavy CPU environment. In fact, it's absolutely fantastic for that, and we use it all the time. We also have a thing called, we do this thing where we monitor the links all over the internet. And what we're doing there is we're saying, is there packet loss in any connection anywhere in the world? And we're building these things kind of like Waze for the internet, right? So we'll look at all of the traffic over the internet in terms of like packet loss and bandwidth available, and then we'll dynamically use or not use connections around the world. And we sell that as a product called Argo. So what we can do is we can say, well, a real example is you're in South Africa, there are 2 cables around Africa, one up the east coast, one up the west coast, and they get congested. And so we'll monitor that and say, oh, that cable has now got a high packet loss, we'll now reroute traffic in this direction. And we'll do that in real time. And there's a single Go process, which is actually looking at the global view of the internet in terms of what's happening on the traffic. The log forwarding infrastructure, that's definitely there. The bot detection thing is quite interesting because we're running a bunch of machine learning stuff written in Go on the edge and actually scoring models, making a decision about this person's behavior. It looks like a bot rather than a human. And I mentioned so many internal tools here. So one of the things that when I asked internally, people started saying, all these examples of things. And one of the SREs said, most of the stuff that we would have written in Python, we now write in Go. So the little tools they use, the internal stuff they need, is getting written in Go rather than Python, or worse, PHP. We have a quick look on, so on one of our edge machines, so one of those machines is in those 194 cities worldwide, There's 71 Go binaries running on those machines, and that is absolutely the biggest language footprint in Cloudflare at all. I think I might have finished. Yeah, I have. Questions? I'm happy to answer any questions.
Don't be shy.
Don't ask a question. Yes.
What's the?
Who are you? Who are you? What's your name?
My name's Tom.
Tom.
What's the biggest problem with Go today, and how do you fix it?
I mean, one way to answer that is why do we write some stuff in Rust? Because we do have quite a lot of stuff in Rust. And I'd say that for something where we want to be very, very close to the hardware, Go is abstracting that away, and Rust isn't in the same way. So, for example, we have released a sort of VPN. It's not a VPN, it's something called Warp, which will connect your phone to us using the WireGuard protocol, and then we will make sure that's encrypted, that connection, and then if you're in a coffee shop or something, somebody can't do something bad to your connection. That's written in Rust because we really needed the closer to the hardware performance and access to I can go if you can go look, for example, you actually need the file descriptor for a connection on the network, some weird thing you want to do. It's very hard to get it. I remember doing something early on with like unsafe and all sorts of nightmares things to get it. Whereas in Rust you can do that kind of thing. The other thing is you can still do sort of crazy stuff in Go, right? You can try and send on a closed channel and panic, and you can get a nil somewhere. So that you can still hurt yourself. And in Rust, because of the way in which it does a lot of compile time checking, it's harder to screw yourself. So, Go has, for all its, so what's really good about Go is you can learn it really fast. Look at me, the 15 days I had, I think 4,000 lines, it was working. It's fast to get going in. A language like Rust is hard to get going in. There's a lot of concepts, a lot of syntax, a lot of ways of thinking. We're actually having a debate internally about, what's the total cost of ownership going to be of the Go programs and Rust programs, and I think we don't know the answer, right? Maybe that safety in Rust really helps you in the long term, or maybe the simplicity of the language really helps you in the long term in Go. It's hard to know. So I would say that it's not really a problem of Go that it doesn't have those characteristics. It's just a fact of Go. It's a different language, and you have to say, yeah, well, okay, it's different, right? It's not always going to be the only language we use, but for a lot of what we do, which is networky stuff that runs in parallel on a lot of machines, it's turned out to be really good. Next question.
Hi, Peter. You mentioned two problems there. One, a recurring problem, which is software distribution, and the problem that you had in the beginning of the year. I'd like to know if that was a software distribution related problem, because I can guess if you're running 71 or 72 Go binaries?
Who knows?
At all the edge locations. I'm wondering, how do you deal with a distribution, taking into account that one bug can take down all of the edge?
Okay. Well, first of all, you'll be happy to know that the outage was not caused by a Go program. Sadly, you'll want to know that it was written some code that I wrote a very long time ago. So how do we do? So software distribution is interesting. We obviously have to do progressive rollouts of stuff around the world. And it actually doesn't really matter to us whether it's a single binary or something more complex. We run an internal apt repository, and we apt get everything onto the machines around the world. But the bigger question is how we do the rollouts. And the short version is we have these, what we call the animals. The animals are different locations around the world. So the first one is called dog, and dog is our dog fooding location. So our employees go through the absolute latest Cloudflare code. So if something goes wrong, our employees see it first. So that's our dog food cluster. Then we have what we call pig, and pig is our guinea pigs. And Is this being recorded? Just cut this bit out.
Live stream also.
No, we've talked about this before, but there are some customers who are they're a negative cost for us, so they tend to be dodgy individuals. They might have paid a stolen credit card or something. While they're still around, they get put in guinea pig, and they're actually the recipients of the latest code of Cloudflare. Because if it falls over, we don't feel too bad. So we actually turn what's a negative thing into a positive for us, because they're our QA department. So that's the guinea pigs. So don't mess around with Cloudflare unless you want the latest code. That's great. And then we have the canaries. We're getting through the animals. And the canaries are actually real live curlos where we can actually roll out what we now think is very stable code. We have a whole process for these rollouts and rollbacks. And then once it gets to Canary, we're pretty sure we know that it's good, then it can go to the whole world, can be pushed out. So your obvious question is, how did you screw up and take out the entire world? Well, it turned out there was a software distribution mechanism that actually used Quicksilver for our web application firewall that I wrote in 2012, which didn't use progressive rollout. In fact, you could just go to an API and go like that, and it would take half a second and globally start executing. And we did something very bad to regular expression, deployed this regular expression in the WAF to the entire world, and went 100% CPU in, well, under half a second. I'm proud of that. And it took us 27 minutes to get it back again. So we have a progressive rollout, and now, of course, we've changed that, so you can't do that anymore. So now we can progressively roll out in the WAF as well. You asked two things. What was the other thing? That was it. Okay, great. Anything else? All right. Well, you can ask me privately if you have some private question that can't be asked in front of others. I will add one thing. I think on the, I think Go has the ease of learning it is actually one of the biggest things about it, which is what I found is that, I would consider myself to be a C programmer. That's sort of when I started doing commercial software, I was an assembly language and C programmer for writing device drivers. And so, coming from that direction, Go was very, very easy to learn. But you also see, people coming from kind of a Python kind of direction, finding Go fairly easy to learn. And you also find newcomers, there's not a lot of syntax. There's not a lot to get you somewhere, and a lot of the attributes, which are like the ease of use, the stability of the fact the language isn't changing, the rich libraries make it something you can get up and running with very, very quickly, as opposed to some of the languages have a higher, introductory cost. What will be interesting to know is how is some of the cost of that simplicity? There's lots of things missing in the language play out over the long term. And we feel like it's actually working fine. We've been doing it for now 8 years, if you include my technical code. But there are other languages. I think Rust has pretty interesting characteristics, and we'll see how this stuff plays out. What I would say is, I've programmed in a lot of different languages. Don't get too hung up on one. There are things will change. I honestly thought Arkham was going to be the future. Maybe one day it will. And I think it's worth understanding the trade-offs in the languages as you build things, because there are things which will appear like, oh, why is it not like that? Oh, that's a little bit like moving countries. It's not like that in some other country. Okay, all right, it's different, and then you'll grow from it. So I think Go is great. It's definitely a language I use a lot. Oh, there's a question.
How much do you code today? Do you have that? Still have that?
Okay, so this is a really painful point for me, right? So I actually did a query today. I did a big query today, so that was actually a pretty big moment. So I have not, so there's actually kind of a joke internally about how much of my code is left. So what happened was, Matthew Prince, actually the CEO, who has a degree in English, he also has a minor in computer science, and he wrote some of the original PHP code, and we got rid of that pretty fast. It wasn't the English language degree, and it wasn't the minor in computer science. It was just the crazy guy with PHP problem. And then I wrote a lot of code in a lot of different languages, and we're slowly removing it. So I have not written anything at work for 2 years, maybe, something like that. Part of the problem is I have 300 staff now, so my job has changed quite a lot. And you know, sometimes I miss it. The big thing actually is I would love to write some code, but I know I won't have time to maintain it. And you know, maintaining code is almost 100% of the time, right? The actual writing is a very small part. And so what I'll end up doing is handing something off to someone who then says, I have to maintain the CTO's code, doesn't dare say anything about it, you know, quietly changes it without me seeing, you know, all that kind of stuff. So it becomes kind of embarrassing. So all they have to debug it. So you know, I would like to do some more, and I think we're actually thinking about the structure of Cloudflare, and so I can do some more stuff. But yeah, not much anymore.
Okay,
Go on. Do you want to use the mic so I can do the question? I know it feels ridiculous holding that thing.
Talk about Cloudflare. Do you have any big projects going on at the side, and what do you imagine for your company for the future?
Okay, so the question is, what's the future of Cloudflare? So we think that there is a fundamental shift going on that started probably at the beginning of 2000, which is moving things that we bought into things that are services. And so if you're old enough to remember Hotmail being created, what was interesting about Hotmail being created was it was a complete revelation that you could have email on the web. It seems completely ridiculous now, but at the time, everyone got email as like an email program that they installed, and then they got an email account from their ISP or their company, and suddenly it was just like, oh, I can log in the web. And Salesforce.com started around a similar sort of time, and there was this big change in software, right? Software you didn't have to buy it anymore. And then, you know, along comes Amazon, I think 2006, and the iPhone a year later, or it's the other way around, I can't remember which way around it is. And you know, suddenly you could just rent computers, right, in the cloud. And also everyone suddenly got obsessed with everything being on their phone, where the accessibility was everywhere. You know, if you think about prior to 2006 or the iPhone and that real explosion, you used to have to go to where the internet was, right? In your house, you had that one computer that was connected to the internet, or you had to go to the office, and suddenly the internet was wherever you were. And that changed, I think, how people think about applications. They expect them to be fast and secure and everywhere, and we live in this world where I can just go to Lisbon and open my phone up and do stuff, right? And so that changed the environment. And then now, you know, the consequence of all this is that there's no real distinction between, you know, using your phone or your laptop and some random Wi-Fi and being in the office or being at home, and you expect everything everywhere, and that's blowing up what was the network. So, you know, the idea of the corporate network, the VPN to the corporate network to connect to something, or I need to get home and dial into my one thing, it's just gone. We just expect the internet to be everywhere, and that changes the architecture, and it's causing a wave where what was hardware and software you installed is becoming services, in this case for the network. So we think that, you know, what's Cloudflare doing? It's providing those same services, and so you can, if you've heard that and you understood it, you can just work it out properly. We have to move all that networking stuff like firewalls and load balancers and all that stuff into the internet, because there's nowhere to install that hardware anymore if you don't have a network to go to. You have to install it inside the internet. So that's what we're doing. And we are doing it for companies, and we're doing it for individuals with 1.1.1.1, which is our DNS service, and Warp, which is our sort of VPN, not VPN service. So that's our idea, is that there's 3 waves of cloud: software first, AWS service, and then now.
How did you get the 1.1.1.1?
How did we get it?
Yeah.
So the 1/8, so that whole range is actually assigned to APNIC, so the Asia Pacific NIC, and they use it for, it's assigned for research purposes to them. So we made an agreement with them, which is that we would not use it for anything commercial. We would offer the service for free, with these very, very strong privacy guarantees, so we're not, you know, using the data to make money or sell ads or anything like that. And they would get access to aggregate data, so not anything private, for research purposes. And the problem was because 1.1.1.1 was that 5? Was that 4? This many, was something people typed in all the time as examples. that was getting about, I think it was 25 gigabits per second of traffic. It's like, just shit coming at it. And so they were quite happy to have somebody else just take that off their hands, and we've got a huge network capacity. So we provide them one-on-one service with this agreement with them, and they then get, occasionally you'll see Jeff Houston will write something about interesting research about who's doing what, where, flows of DNS around the world and stuff like that. So that's what we did with that. So. Yes.
How much of our code base has testing coverage?
Yeah. How much has test coverage? I actually don't know the answer to that. That's a good question I should ask somebody internally. Cloudflare, when I joined, I think I was the first person who wrote tests. It was very interesting. So I was the 24th employee of Cloudflare, and Lee Holloway, who was the technical founder of Cloudflare, he had it all in his head, and he wrote it all. Right? He wrote everything. The PHP front end, the distribution mechanism. We were using a different key value store at the time called Kyoto Tycoon. He had the whole thing, and there were sort of some system levels tests, but they were kind of smoke tests. And in fact, one of the first things I did when I turned up was I was like, jolly programmer, I'll download Cloudflare onto my laptop and I'll be able to build it, right? I'll be able to make and get myself a Cloudflare, and that's obviously my development environment. And I never achieved that. In fact, no one achieved that for about 4 years until we built this thing called CF Setup that lets you actually get somewhere. So it was a very weird environment. In fact, that program I wrote, the Railgun program, it had a full set of unit tests, it had this system test suite, it had this performance suite that was doing all sorts of crazy stuff to it. And I think that was really a bit of a revelation at that point. People were like, wow, we have tests. Now, I don't know what the actual coverage is now, but I would say that for anything that's written in Go, because of the fact that Go has amazing testing and it has the perf stuff as well, we have pretty good coverage. Some of the really ancient stuff, I'm sure we still don't have coverage, but we know it's stable because it's been running for 8 years. So. Testing is still alive, so Darwinian testing. So.
Did you have testing for the regular expression thing?
We did, and that's just one of the interesting things. So the regular expression thing which brought us down, I wrote that, and the original thing, and there was an extensive test suite. Both unit tests and actually system tests, because it's a WAP, so you've got to test, does this get blocked, does this come through? But we didn't have anything that looked at performance. And so we had things that did very micro benchmarks. We didn't have something that would say, was there something running away? And actually it's a tragic story because the software actually had a mechanism in it if something ran away to kill it. And we did a refactor and it got removed. And so, it's one of these things like, why did the plane go down while the pilot was in the toilet and this other thing happened and, all this kind of stuff. And so if you look at I read a very extensive description of what happened and, these sequence of things had to happen. But no, we didn't have a test that would have covered that. Of course we do now, but that's never going to happen again because they haven't written a test for it. So. Is the pizza here yet?
I think it should be arriving right now.
All right, so why don't is there any more questions? All right. Yes.
What is the worst outage that you guys had in the past 8 years? And
we've only had 2 where it was actually took the whole thing down. The other one was, I think it had been 6 years since we knocked it offline completely. One of the things that's interesting is we get attacked all the time by people with DDoS attacks because we say, we actually have a blog post where the CEO is like, write a blog post saying, we're the best, bring it on. And everyone internally was like, seriously? He's like, yes, do it right now. So we did. And people threw all sorts of stuff at us, but we didn't get knocked offline. If we've gone offline, we've foot-gunned it ourselves, right? We've shot ourselves with something. The worst was actually the one in July. It's by far the worst. Because at that point, 20 million domains, the whole thing went off. And it's funny, I was in a meeting and my watch, PagerDuty, comes with my watch and it says, global traffic drop. Now global traffic drop is our worst page because it's the externally measured, our traffic has dropped by a huge percentage. And we'd had a number of false positives on that thing, so I was like, oh yeah, it's that one alert, this keeps going off. And so I didn't come out of the room for about 2 minutes, and then I stepped out of the room because the meeting ended, and I walked through the sales department. One of the guys who's one of the very technical sales engineers said, it's an 80% traffic drop. And 80%, you know, I knew that we were really in deep trouble because of just the scale of what we were doing, and it was global. And it took us 27 minutes to get back online by actually using a feature flag to kill a feature. So we have feature flags for absolutely everything. And we basically, myself and the lead person, and it's actually one of these really weird situations where normally I wouldn't be in charge of an outage. You actually don't want an executive in charge of something like that because it's an executive, there's a lot of weight, and people think, oh, you know, they get worried about how they behave. You actually want the team itself. But I happened to be there, and they said, hey, John, come in, sit down. And after, very, very quickly, because we had good observability of the whole thing, we knew which component exactly was causing the problem. And actually, I was sitting here, it's funny, it's like you could have made a movie set. I was at a long table, and I was sitting at the head of it just randomly because that was a seat that was free. And all these people, and like 3 people said, we know it's X. Like we've looked at it in 3 different ways. Right? We've got this monitoring system over here, we've live S-traced it on the machine, like literally logged into a machine and run S-trace. We've looked at these 3 things, and we're like, okay, so we use this feature flag to kill it. And the thing is, you're going to kill a feature and shut it down, and it's going to bring us back up, but that feature's now dead for 2 million customers. And literally, we're like, should we do it? And everybody turned and looked at me, like the whole room, like in a movie, like, should we do it? And Matthew, the CEO, was like, my phone is ringing, because of course he's freaking out. And I was like, yeah, I wish there was a video, because I think I said it really quietly. Like, yes, let's do it. And so somebody hit James, who I worked with for a really long time, was one of the original people in London. He's like, enter, and it instantaneously we came back. Because guess what? Quicksilver, which was still working, and this was the point about that Unimog thing is, if Unimog had taken the machines offline, because it had thought they were overloaded and that they were actually dead, mistaken to be dead, we would not have been able to come back up without actually KVMing into the whole world and rebooting. And so what happened was we hit that, Quicksilver distributed in half a second, everything came back on. And then we went through fix the actual problem and get it back on again. And to his credit, I have to say this to his credit, Matthew, I don't think we'd had an outage like this, and he called me, and I have the record of the call, 7 seconds long, and he said, what's going on? And I said, I have no idea, because I hadn't got in the room yet, and I had never done this before. I just hung up on it. I literally just hit, I want to talk to you, but you're not going to help me, because the worst thing was the CEO now, and you're then. And then what was really great was, when we came back online, he sent me a text message that said, let me know when I can speak to you. And I'm going to be forever grateful for him not calling me back, because we were in a really tough situation to get it back on again. So, yeah, don't knock off 20 million domains in the middle of the day. Really, really special.
Yeah, pizzas are here now.
All right, so I'll shut up. This is more important. Thank you for inviting me. Have fun with Go.
So, if you want to go outside, there's seats and salsa right there.
Olha tu. Como assim? O que está ali no laptop da nossa equipa a fazer?